So this video is integrated one. This is the homework 8-70 to 8-76. So on the very first problem here, we are going to try to write the equation of an exponential graph in the form y equal a times b to the power x. So first thing I need to do is look at these points. So I have a point at 0, 4. This is going to be my y-intercept. So that is going to be our a. So our a is going to equal 4. Now this other point here is 1 away from that. So that's going to be 1 comma, and it's 3 up. So it's going to be 1 comma 7. I'm going to be putting that in for my x and my y to figure out my b. So I'm going to have y is equal to a. Again, my a is a 4 times b to the power x. And then I'm going to put in that point 1 comma 7 for my x and y. So I'm going to have 7 is equal to 4 times b to the power 1. Now, the nice thing about b to the power 1 is that's just a plain old b. So I get 7 is equal to 4b. Divide both sides by 4, and my b is 7/4. I would just leave it like that. So our equation is going to be y equal 4 times 7/4 to the power x. That is our equation. Now on 8-71, we're dealing with sequences, and they want us to write it in standard form. That means that we're going to be writing it like an explicit equation. So in this first one, I noticed that it looks like I'm adding 1,500 each time, which means that this is going to be arithmetic. So since this is arithmetic, I'm going to write this two ways. One way is to start with my first term, okay, my a sub 1, let's say, which is 500. And what am I doing to 500? I'm adding 1,500. Now, since I'm starting with my first term, okay, let me do it this way. Since I'm starting with my first term, not my 0 term, this is going to be an n minus 1 because I'm starting with my first term. That's your equation. Now, some of us might want to go backwards and find our a sub 0. So if I was going backwards, I would be subtracting 1,500 to go backwards. And so when I'm subtracting 1,500, I'm going to get a negative 1,000. So another way to do it is to start with your a sub 0, negative 1,000. We're still adding 1,500, but if you're starting with your 0, then this is an n. This one appears in n minus 1 because I started with my first term. This is my first term, not my 0 term. Either one of these is acceptable. Okay. In the next one, it looks like we are timesing by 5. That's what it looks like we're timesing by. So that's going to make this one be geometric. And so I'm going to start a sub n. I'm going to start with the 30, which is my first term. I am timesing by 5. And since I am starting with my first term, okay, since this is a sub 1, then I'm going to raise this to the n minus 1 because I'm starting with my first term. Now, just like the last one, if I want to go backwards, I can go backwards and find my 0. I would be dividing by 5 if I was going backwards. And so if I divide by 5, I get a 6. So I could also write a sub n is equal to 6, which is my 0 term. Sorry, this is a sub 0, times 5 to the power n because I'm starting with my 0 term. Again, either one of these is an acceptable answer. On HS72, write 1 or 2 equations to represent the following situation, then solve. Be sure to define your variables and clearly answer the question. So in this situation, we have here Katie's garden. In Katie's garden, there are 105 ladybugs, and they are increasing by 2 ladybugs per month. there are also currently 175 AFibs, and they are decreasing at a rate of 3 per month. And the question they want us to figure out is, when will the number of ladybugs and aphids in the garden be the same? Okay, so I am going to define M for number of months, because that's what we're trying to figure out, is the number of months. So I'm going to be writing one equation for ladybugs. So for my ladybugs, I'm going to start with 105 ladybugs. We are increasing by 2 per month. Okay, that's my ladybugs. Now the AFibs, I'm going to be starting with 175, and they're decreasing by 3 per month. Now I'm going to solve this system by using equal values, since they're both y equal. So I'm going to go 105 plus 2m is equal to 175 minus 3m. I'm going to add 3m to both sides, and I'm going to get 5m plus 105 is equal to 175. I'm going to minus 105 from both sides. I get 5m is equal to 70, not 75, sorry, 7d. I'm going to divide both sides by 5, and when I do, I'm going to get 14. So 14 months. That's our answer. Now, if they wanted us to say how many that would be, I could take that and I could put it into either equation to figure out how many that would be. So if I put it into my ladybugs, for example, I get 105 plus 28, and that's going to give me 133 ladybugs and also aphids that they would have the same amount. On 8-74. So on this one, we want to pay attention to what they are asking us to solve for. This one they want for y, this one for x, this one for r squared. So we need to be careful. So in this first one, I am going to be getting my y by itself. So I'm going to add 3x to both sides. And I'm going to get 5y is equal to, and I can do negative 10 plus 3x, but I think I like it to look like this, 3x minus 10. I'm going to divide everything by 5. And I'm going to get 3/5 x minus 2. And that's your equation. Now on B, they want us to solve for x. So what I'm going to do is I'm going to minus b from both sides to get my mx by itself. So I'm going to have a y minus b equals mx. I'm going to divide by m, and I could divide each of these separately by m, but since nothing's going to simplify, I'm just going to divide the whole quantity, that whole side, by m. And I get x is equal to y minus b all over m. Okay, and on C, this one you want to be careful. This actually is the equation of a circle, area of a circle, pi r squared. They want to solve for r squared, not for r. So that's a little less work we have to do. So I'm going to divide both sides by pi, because pi, which is just a number, it's an irrational number, is multiplying with r squared. So I'm going to get a over pi is equal to r squared, and I am done. That is our answer. On 78-75, so this one I added on everything you see here, length of AB, AC, BC, and any special relationships in the graph. That was not in the packet. So if you're doing it in the package, you're going to have to get some graph paper out and do this. Okay, so I'm going to be plotting these points, 3, 0, 2, 7, 6, 4, and let me label this A, B, C, And then I'm going to connect this. So let me draw, oops, line rectangles. So I'm going to connect A with B, A with C, and C with A. Okay. Now to figure out the lengths and the slopes, let's first focus on AB. Okay, so AB, I'm going up and over. So I'm going up 1, 2, 3, 4, and I'm going over 2. So up 4 over 2, that's going to be the slope here. So the slope's going to be 4 over 2 or 2. Now, when I want the length, I'm going to do Pythagorean. 2 squared plus 4 squared equals c squared. So I'm going to get 4 plus 16 is equal to c squared. So that's a 20. So this is going to be the square root of 20. Okay, so now let's do AC. Okay, so AC, here I'm going to be going up 1 and across 6. So up 1 over 6. So my slope is going to be a 1, 6. So my two slopes are different. Then to find the length, I'm going to go 1 squared plus 6 squared equals c squared. So I get 1 plus 36. So that's going to be a 37. So I'm going to take the square root of 37. So far the two lengths are different and the two slopes are different. And the slopes are not negative reciprocals either, because that would make them right angles, but they're not. So now let's do BC. So I'm going to be going down 3 over 4. So this is going to be a negative 4/3. So none of the slopes have any relationship with one another. So we don't have parallel lines at all. We don't have perpendicular lines. Okay. Now let's figure out the length. So I'm going to do 4 squared plus 3 squared equals c squared. 16 plus 9 equals c squared. That's going to be a 25. And when I take the square root of 25, I end up getting 5. And so that is going to be my length. So looking at these, in terms of what's special about them, the three sides are totally different. One's a square root of 20. One's a square root of 37. The other one's a 5. None of the slopes are anything special. They're not parallel. They're not perpendicular. So the only thing I can say about this is, since all three sides are totally different, this is going to be a scalene triangle because all three sides are different. On 8-76, we want to decide if these graphs are functions, and if the relation is not, explain why. Okay, so remember, if something's a function, then I can use the vertical line test if I am dealing with a graph. So let me just get a vertical line drawn here. Okay, so that's going to be my vertical line. Now, if I take this vertical line and I move it across the graph, and everywhere that I move this, it only touches at one spot, which is happening here, then this is a function. Let me just move it off to the side. So this one is going to be a function. Passes vertical line test. And basically what happens when I'm using that vertical line is I'm trying to see if each x has one y. So I'm putting in parentheses, each x has one y. So now I'm going to take this vertical line over here, and you can see as I'm going across, for example, right here, I'm at -1. I have two different y values. I have a y value here. I have a y value here. That is going to fail the vertical line test. And as I move that across, it's going to touch more places. So not a function, fails vertical line test. Because it touches at more than one spot. some x's, and really there's an infinite amount, have more than one y. Okay. So that makes it not be a function. And then on this last one here, we have a bunch of points. So as it come here, okay, at -4, that's okay. -3 is okay. But when I come here to -2, what's happening is it touches at 2 places. So not a function, fails vertical line test. Now it fails it in general, but it fails the vertical line test for x equal -1 because that x has more than one y. And that's the end of this video, and hopefully that helps you with the homework.